Compilers and interpreters. Compilation and interpretation is a form of language processing. Why do we talk about this, though? The type of language processor that was used to create a file is relevant to the tools that we use to analyze this file. So in general, the process of reverse engineering is an attempt to reverse this process of compilation. So to understand how we reverse engineer something, we need to understand how this file was created in the first place. There are roughly three types of language processors. We have compilers, interpreters, and hybrid compilers. With the examples listed here, but yeah, we will look into each example in a little bit more detail. Now, what does a compiler do? A compiler is, roughly explained, some form of translator. So it gets a source code, for instance C source code, and compiles it to machine code. The machine code is understandable by the computer and can be executed. So here, for example, C code is transformed into machine code by GCC. The hybrid compiler has two steps to it. So there is the source code that is transformed by the compiler into an intermediate language representation, also called bytecode. In the case of Java, that would be Java code, which is turned into Java bytecode, and that is something that you see in the .class file. At runtime, the intermediate language representation, or Java bytecode, is executed via a virtual machine or interpreter. That means every system that wants to execute this Java bytecode needs to have a Java VM installed. But this has the added advantage that it does not matter what kind of platform you have, what kind of operating system you have. Every machine that has a JVM can execute this code. So it's a platform-independent way of shipping your binaries. And what we see here in red, that's the part that you as a reverse engineer will get. That's what you have in front of you when you want to reverse engineer the file. So similarly with the compiler, you get the machine code, but in case of the hybrid compiler, you get the intermediate language representation. Interpreted is, well, the easiest of them. So you just have the script, there is no compilation, and at runtime, this script is executed by some form of interpreter. In this example, it's JScript, which is executed by cscript.exe, and that happens at runtime. But that means you as a reverse engineer have the script in front of you, and that's like the high-level language representation. So that's the best case. So what does this mean for our tools of choice? Now, as a reverse engineer, we either get machine code, bytecode, or the original source code. If we have machine code, a lot of information has been lost during the compilation process. And for that reason, decompilation is often difficult and not accurate. Whereas disassembly is a little bit more accurate. So our main tools will be disassemblers and decompilers, most of the time side by side. To analyze compiled code or machine code, you put them both into disassembler and a decompiler, and then what you get is from the decompiler some sort of pseudo-C, so some high-level language representation that might be not that accurate. And you also look at the assembly code, which is a low language representation for the machine code that humans can read. By moving that side by side, you can control if the pseudo code does not look like it's supposed to. You can check the assembly, and the pseudo code, on the other hand, is easier to understand if it is correct. So what do we do if we get bytecode or intermediate language? Now, in contrast to machine code, this preserves a lot of information. It usually has a lot of metadata, including the original function names. And that means decompilation usually works very well and almost resembles the original source code. This assembly can sometimes be necessary, but only if the person who created this file consciously decided that they want to make our lives harder by applying anti-reversing techniques. Main tool for us is usually the decompiler. So, but as I said, you also can use a disassembler. So I'm showing you both cases here. The decompiler transforms the intermediate language into a high-level language. So, for instance, Java bytecode will be transformed into Java code. The disassembler here, for example, Java P, will transform the intermediate language into a form of intermediate language assembly. In this case, for instance, Java bytecode assembly. So what do you do if you get a script file that is interpreted? That's the easiest case actually, because you don't need to transform it. It wasn't compiled or transformed in any way. Well, given that the script was not obfuscated, but we will talk about this later. Now, this kind of source code, the best way to analyze it is using some form of text editor or IDE. For example, you can use Notepad++, you can use Visual Studio Code, anything that provides some form of syntax highlighting at least. But how do I know what kind of binary I have there? What if it's bytecode, machine code, or anything else? Well, this is a topic for triage. And triage will tell you exactly what kind of file you have in front of you. There are some misconceptions or myths that are very popular beliefs, but they will make it harder for you to understand how reversing works. So let's get rid of them. The first one is languages are compiled or interpreted. This is wrong, because if something's compiled, interpreted, or if there's a hybrid compiler used, it's not an inherent characteristic of a programming language. It's a characteristic of a language implementation. The thing is that anyone can write a compiler or interpreter or hybrid compiler for any language. For instance, there is a machine code compiler for Java called GCJ. So you can compile Java into machine code. As a malware analyst, you might see non-standard language implementations for the very reason that tools often do not exist for rare implementation. So the tooling might be worse, and malware developers might use those rare implementations just to make your life harder. And that is why you should get this out of your head. This compiled, interpreted is not a characteristic of a language. It's a characteristic of a language implementation. I also hear very often is Python is interpreted. Well, of course, interpreted is not a characteristic of a language, just as we said. But let's talk about the most common implementation of Python, and that is CPython. In CPython, that's what you see most of the time when you analyze Python-based malware. CPython source code is compiled to Python bytecode, the so-called .pyc files. Most of the time, when you deal with Python samples, you will have the CPython bytecode when analyzing them. So actually, CPython, the most common implementation of Python, is a hybrid compiled implementation.